What's going on, ladies and gentlemen? Thank you so much for tuning in. If you have an antiquated HVAC system in your home, whether it's a heat pump, gas furnace, or strictly straight cool, you guys may want to check out this video. I'd like to give a shout out to the folks over at Senville. You can find them on Amazon, online. They make budget-conscious heat pump HVAC equipment. And standing next to me is their 55,000 BTU side discharge vertical heat pump and their indoor 60,000 BTU air handler. It uses heat pump technology. So basically what that means is in the summertime, we're extracting the heat from inside your home, making the air cooler, and discharging that heat outside. In the wintertime, we're going to extract the heat from, believe it or not, when it's 20 degrees outside, we're extracting the heat from that air, and we're going to dump it inside your home. Because there's a component inside the outdoor unit called a reversing valve, which allows us to reverse the flow of refrigerant. So instead of sucking the heat from inside, bringing it outside, it's going to take the heat from outside, bring it inside. So I'd like to give a special shout out to the folks over at Senville, and we have decided to give this installation to one lucky new homeowner in our service area. They're getting a brand new heat pump installation during this video for absolutely no cost. Zero, bupkis, nothing. Free, zilch. Make sure you check out this video. Let's go! What's going on, ladies and gentlemen? The day has arrived. We got a couple inches of snow last night here in the great state of New York. Pulling up to the shop. We're gonna have to defrost the trucks. Jeez, wow. Anyway, the day is here. We're gonna be installing that Senville 60,000 BTU 5-ton heat pump unit. They got oil heat, and it's a perfect storm. The day before they closed on the house, the local town repaved the entire neighborhood. So there's a 5-year moratorium on opening the road so they can't bring the gas to the home. Ain't that crazy? We had originally proposed an oil to gas conversion featuring a tankless combi from Europe to replace his old and decrepit oil-fired boiler that provides space heating for the home. And I was like, listen, you could spend tens of thousands of dollars, or how about I got you? The folks over at Senville have been wanting me to put in their AHU Series ultra-high efficiency ducted heat pump system. So not only will it provide high efficient cooling during the summer months, but comfortable space heating utilizing a heat pump inverter. The same system works in reverse in the winter. Imagine that. All right, ladies and gentlemen, we're on the job site. We got snow. It sucks, but the show must go on. So we are taking out an existing Rheem 5-ton, 60,000 BTU, R410A central cooling system only. It's cooling only. We are going to reutilize or repurpose the existing line set to work with our new side discharge condensing unit, which will be outside here. We're going to mount it to a wall-mounted bracket to the wall here, elevating off the ground because it can be used as a heat pump. This unit right here, I think this is a 13 SEER system. Yep, 13 SEER. This is Rheem's builder's grade, central AC system only. Standard compressor, single stage, 1 speed. It's on or off. One of the main benefits by using an inverter like the Senville heat pump system is that we have multiple stages of cooling. It's the equivalent of giving yourself a dimmer switch for your HVAC system. It's a win-win situation. All right, it's not every day I'm in an attic, and it's also not every day that I have a path that's kind of with plywood to get to my air handling unit. In the Northeast, our central AC systems, the air handlers are typically in an attic. Sometimes they're in a crawl space or basement, but very rarely are they in a garage or closet on the first or second floor. It just doesn't happen like in other parts of the country. So one of the first things I'm going to make sure that we have is 240 volts, and we have 115 present here. We're going to have to do something about that. Wasn't anticipating that. We have a 115 volt air handler. We need 220, 240. We may not get lucky with power. Turn. Okay. We're installing the Senville 5-ton outdoor vertical discharge or side discharge heat pump condensing unit on the rector seal, wall mounted bracket, holds up to 300 pounds, so we're well within our limitations for that wall mount bracket. We took a measurement from left to right and making sure we're square with our feet on the bottom. And I'm going to jump in here and give him a hand. Peter, you got the light side.
I know, I'm pressing the fence. Higher view.
What's that? All right. We got one in there. Okay. We're gonna have to balance this a little bit and push that off the wall because we're a little top towards the out a little bit, but not too shabby. All right, here's the air handler. Right now, we are going to go from a horizontal left to a horizontal right, and that's going to involve flipping the evaporator. So let's flip the evaporator so our drain is on the bottom, and that way any condensation that form will gravity drain out. All right, so step one, remove filter cover. And this thing is magnetic. Look at that. That's beautiful. Okay. Filter cover. And check out this filter. It's wrapped with a fabric. Wow. You know, you could spend, Peter, 3 or 4 times the price and get a cheap plastic filter in a carrier or a ream. True. And here you go for a fraction of the price. A quarter of the price, you get a nice filter. And you don't have to putz around with screws that rust and you lose them and they get stripped. Beautiful, okay. Step 2, remove upper cover assembly.
I haven't filled up
no.
That's weird.
It would be nice if we were able to get our 1/4 inch and 5/16 Malco driver in there, but it is what it is. Okay, remove that upper cover assembly. Beautiful. Exposing the blower compartment, optional electric coil, control boards. Step 3, remove the evaporator cover plate. Evaporator cover plate. And we're probably gonna have to remove this cover as well. Step 4. Indication of the position of each temperature sensor of the evaporator. We have the 60K model, so we have 4 sensors and the electronic expansion valve. That bad boy. Unplug temperature sensors, T1, 2, T2A, T2B, and the electronic expansion valve from the control board. From that control board. All right, I am not going to follow directions. I think it's quite too much going on there. We removed the duct ties that were holding all the wiring to the evaporator. We pulled the evaporator out. We flipped it over, put it in, and now we're going to screw everything back in. Easy peasy. Make the folks at Senville quite happy. Don't you wish you had that little baby forklift in here? We could just like... That'd be dead. Let me stop cursing. What are you...
It's wet on the bottom, so I'm like slipping.
Oh.
Take the gloves off. Push towards me. When you're done up.
Just...
What are you doing? It's a push. I'm trying. You pushed it back. Or we could just lift it up over the ledge.
A few minutes after 11 here. Our air handler is in position. We reverse the evaporator. And I button everything up. And I was reading that sticker there. And it says when you change the direction of the airflow, T1 sensor must be changed. Now this T1 sensor was inside that little rubber grommet hole. And that would have been the airflow coming in this way when it was discharging out the left. Now it's coming in from the left and going out the right. So that sensor is sensing that air temperature before it hits the evaporator. So we moved it there as indicative in the factory instructions. And now we're going to button all this back up together. I got my wiring. I have 10 conductor wire from my outdoor condensing unit. We still got to button this up a little bit. And that's going to go to this control board. I have my thermostat that's factory supplied, wired with those 2 conductor wires right there. And I was reading the manual, and what's pretty cool is that sensor, that first block on the left side of the screen right now, that first green block with the 3 terminals right there, there's a little black little jumper right there. If we pull that out and we wire a flow switch to that block right there, we'll get a float switch error. That's pretty epic, by the way. That is epic. A float switch error, when it's wired, is phenomenal. Unfortunately, the budget doesn't allow it. In this case, where we're using the existing emergency drain pan, we are going to be working on this duct work. It's old duct board right now. It's literally falling apart. But what's great about the Senville is that it compensates CFM based on ductwork. Awesome. Awesome feature. All right, so I'm about to start the low voltage wiring here. And all of these screws on the terminals Well, they're all tight, so you need to loosen them up first, which is annoying because they're always like unscrewed and they don't get lost for some reason. So we have R, C, so on and so forth there. There's our conductor wire, 10 conductor wire. We're gonna use 8 of them, and then we'll match this up outside. Okay, let's do take 2 on the thermostat wiring. If you're using non-polarity RS485 communication, we have the wired controller, which is getting 1 wire. Interesting.
Is that what it says?
I only see 1 wire here. Wired controller.
That's impossible.
Well, that's what it says. I only see 1 wire there. So, nonetheless, hopefully this is okay. Our outdoor unit, we're wiring with S1, S2 to S1, S2. We had, and we still do have 8 conductors wired from RC to L to B to Y1, Y2, W1, G for fan. We have all that wired in, and then we're like, we have 2 other conductors remaining, and then we saw this on the inside front cover of the air handler, non-polarity RS485 communication. So our gray and our black wire is going to be our communicating wires. We're going to leave this attached for now. Hopefully that works fine. We still got to figure out those dials, but see, for setting power, DC motor model only. I don't know, but we have a bunch of error codes there. Hopefully we won't need it. And hopefully you don't get like an EC07, which is ODU, fan speed, out of control. All right, as you can see, I have been digging into that plug for quite some time. Of course, these are nice and loose. This is the trick. A pair of line wire strippers. Got it right out. See? But that was super, super tight. There's our hole. All right, it is about 20 minutes to 12 here. Made a lot of progress. Now, I have myself on the job. I have 1 other technician, and I have our office manager who is also an apprentice. So we have 3 guys on the job. We started a little after 8 o'clock here in the morning. And I think, all things considered, not too shabby. We are going to size up all the ductwork and replace all the ductboard with a custom fabricated main plenum. And then we'll have flexible connectors that don't exceed 25 feet on each run for each branch off that main plenum. Because what I have here, while it is okay for most, and we did make this special transition piece to go from our supply side of the air handler to our ductboard. This ductboard is falling apart. This, I just can't keep this. And I gave the homeowner an attractive price to replace it. So we're good there. Now our return plenum, nice special box there. Fits in there perfectly. Got a little mastic tape on top, all the sides. We're going to come out of the top with our 18-inch return plenum flex. Should be easy peasy. Peter's got pieces so we can connect our 7/8 and 3/8 to the flared connection on this air handler evaporator coil. I love this. It's the same as it outside. They should make all systems this way. Flare nuts. Easy peasy. All right, I cracked open my plastic cover on the 7/8. We have that nice nitrogen charge in the evaporator, so no damage during shipping. Nicey nice. And let that discharge that high pressure, and then hook up our factory supplied flare connection, union to our evaporator. You know what? I think this is going to be the first ever heat pump or central AC system that we've ever installed without having to get the brazing rig.
Really?
Or nitrogen to flow nitrogen while you're brazing. They have flare connections on the 7/8 and the 3/8, both on the indoor and outdoor unit. We cut off the swedged ends where it would make it a female, so the copper tubing can slide into the fitting like we did right there, right? We used a zoom lock coupling on the 3/8 and a zoom lock coupling on the 7/8. Made our connections without a torch. We reduced liability, burning down the house. You know, some jurisdictions you need fire watch, flame watch. Less insurance liability, less risk of contamination getting into the refrigeration cycle circuit if you're not purging enough nitrogen, or you don't purge nitrogen at all. But this really came out nice. We're going to cut this back, this Armorflex insulation on the 7/8 piping. We're going to wrap the nuts with the insulation that's factory supplied. We'll put the cover on, and God willing, we'll be able to fire this up in a moment. All right, let's take a peek outside. We had set the ladder up to run that 10 conductor thermostat wire. Probably not going to need it. It's nice. It's nice. I would have liked to have used the wall mount bracket, but the condition of the wall, because of the way this was installed, yeah, not too shabby. A filter dryer. I'm gonna pretend this is like a ductless mini split system. Beautiful. All right, the thermostat looks pretty cool. Nice, square, modern looking. I held down the timer button for a few seconds, and that brings up the days of the week. I can use the arrows to set the day, hit the timer again, and it'll allow me to change the time. Now, it's 12:36 here. So take a look at this. Okay. 1, and then it goes to 0. So if you hold timer and day off, you can switch the format of time to 12 to 24 hours, but it's not 0:36 p.m. It's 12:36 p.m. We're gonna put that into 24-hour time, and they'll get used to military time. All right, so we're now gonna do the vacuum process. The outdoor condensing unit is connected to our 7/8 and 3/8 with the flare fittings, also utilizing the zoom lock. So there's no brazing, no need to flow nitrogen other than testing for leaks. We're using the AHU tools, the True Blue evacuation kit. This allows us to pull a nice deep vacuum. Industry standard is 500, but my company would like to go to the teens. Uncut, unedited, raw. You're welcome, Senville. Now, one of the great things about using the right tools for the job is that it allows us to do our job more efficiently and more effectively. If you're not using the right tools for the job, if you're using your manifold to vacuum down, you're not going to be at 10,000 microns like we are already. 8,000, 7,000, 6,000, 5,000. I think I'm BSing you. There's it right there. We're using the Blue Vac Plus Pro micron gauge. We're at 2,700 microns, 2,400 microns, 2,000 microns, and dropping consistently. When we utilize the Blue Vac Plus Pro micron gauge by AHU Tools, we're able to do a decay test. And essentially it's using an app with a formula, and it'll measure the vacuum rise or the pressure rise once we reach below 500 microns. So we like to go to the hundreds, even under 100 if possible. We've gotten some systems into the, I think, 35 or 40 microns. And the decay test, we're not getting above 80. We're getting all that moisture out of the refrigeration circuit. 470 microns, 440 microns. This is just amazing. All right, what do we add to in the micron range?
79 and dropping, but once I close it, it's gonna shoot up.
We're reading the manual. Just look at some line set specifications, minimum, maximum. We're at 60,000 BTUs, so we're going to be a maximum length of 213 feet and a maximum drop in feet of almost 198.4 inches. We're going through the manual. We're also talking about oil traps. An oil trap must be installed, keep this in mind, for every 20 feet of vertical suction line riser, and also every 32.8 feet of vertical suction line riser. So keep that in mind, oil traps, if you're going to be over 20 and 30, almost 33 feet. We're looking for adding refrigerant, because there's a note here. You can see there, it says note that to make sure the additional amount of refrigerant to be charged is based on the pipe size and length. Refer to installation instructions for details. And if it's incorrect installation, we'll F things up. So we're going on page 25 of the installation manual for this Senville, and note on adding refrigerant, and it says that it makes kind of sense, but as a professional in the HVAC industry, it's kind of weird. Some systems require additional charging depending on pipe lengths. The standard pipe length varies according to local regulations. For example, in North America, the standard pipe length is 7.5 meters, 25 feet. Okay, if you want to tell me that, I think most line sets are well into 50 feet, if not more. In other areas, the standard pipe length is 5 meters, 16 feet. The refrigerant should be charged from the service port on the outdoor unit's low pressure valve. The additional refrigerant to be charged can be calculated using the following formula. Now, utilizing this page, it gives us a hint that looks like Senville will be switching over to R32 from R410A once they deplete their stock and start manufacturing new equipment. But our metering device is on the inside unit, because that's that EEV, that electronic expansion valve. And our liquid line diameter is 3/8. So we're gonna need to add 0.69 ounces, or almost 0.7 ounces for every foot, I guess over 25 feet. Now we have roughly 25 feet of line set, so we're good. And of course, never mix refrigerant types. All right, we've been vacuuming down for about 15 minutes. We are at 53, 52 microns. We're gonna do a decay test right now. We're gonna close that service valve on our 7/8. We're gonna close the recovery valve. There you go, we're jumped up. We're at 79, 80, 83, 85, 86. We're doing a decay test. We're gonna see how high this goes, and if it passes, we're golden. 96 microns, 97, 98. 100 microns, 101. There you go, the decay has passed at 109 microns. Industry average, industry standard, 500. We go above and beyond. Just a heads up, Daniel, in the installation manual, they say open both ports gently. They don't specify which one to open or close first. So just remember, just open gently. Okay. Page 24. Open valve stems gently. When opening valve stems, turn the hexagonal wrench until it is against the stopper. Do not try to force the valve to open further. Ensure the hexagonal wrench is inserted to full depth of socket. Failure to do so, or use the stepped service valve tool, may result in a stripped and unusable socket. removing the micron gauge so we don't get high pressure hitting it. Now Daniel's going to open up the 7/8 service valve, gently opening it, and now fully opening or back seating the valve. And once power is restored to the outdoor unit, we're going to cycle the system in heat mode and fire up. All right, we put the thermostat in 24-hour mode. Let's power on. Let's change the mode to heat. And let's raise the temperature. Let's go to 85. All right.
Get going.
Excellent. The thermostat is set to heat mode and it's set to 85 degrees. Beautiful. Any thoughts, feedback, criticism?
It's nice.
It's nice. You know what? I happen to really like the air handler. I was more one-on-one with it, like you were one-on-one with this outdoor unit. But it's very nice.
It's straightforward.
Straightforward, communicating.
You don't have to even open up this to get in.
No. You don't have to open up the front cover of anything. The electric is all right there. You know, you have the other brands like Fujitsu, Daikin. You got to take the thing apart to wire it. It's just, this is so straightforward and simple. And the best part is it's a communicating inverter ducted system available in 4 sizes: 24,000, 36,000, 48,000, and 60,000 BTUs. That's 4 different tonnage sizes, 2 to 5 ton, one system for every need. All right, I'm gonna now use a thermal imaging camera. We're gonna make sure that we have heat coming out of the vents it's supposed to, and properly finish commissioning and start up of the system. And we're out of here. What's great about thermal imaging cameras is that you can also see efficiency loss. Look at the cold air around the center of this diffuser. And then above the corner of this window. Ooh, that may be some water damage actually. Beautiful, beautiful. All right, ooh, nice and toasty up here. 90 degrees discharge temperature. Another one close to 90, beautiful. Here's one in the master bathroom. Beautiful. Kids' bedroom, nice. Another kid's bedroom, also very nice. Wow. Now, for those of you who know me, I have a reputation in the neighborhood for being an expensive HVAC contractor. Why? Because I install quality equipment and material for my end users, the homeowner, the client, the property owner. But I gotta admit, despite Senville being an internet brand, I'm impressed. I really am impressed. So thank you, Senville. And thank you to our residential client for allowing us to install this system in their home. It sure beats oil, that's for sure.